All right, Math 12A, we have finished Chapter 8. So we have finished the last two sections. I'm recording this at about 7:30 at night on, oh my goodness, days are running in, Wednesday night. No one has asked me any questions yet on law of sines, law of cosines. You have time, it's okay if you haven't. But I don't have anything specific to go over with you. We are going to have a test on section 8.5 and 8.6. There are 6 types of questions I could ask you, and I'm going to briefly go over those. It was asked of me to not have the test on Tuesday because someone has a presentation to do that day. I'm fine with that, but that means I would move it to Wednesday. So again, moving the test to Wednesday, please let me know if that does not work for someone. I do appreciate that person letting me know so that we could make adjustments as early as possible. So if Wednesday doesn't work for you, please tell me and we will figure something out. So section 8.5 and 8.6, there are 6, 1, 2, 3, 4, 5, 6 types of questions that I will be asking you on the test. The first part is a line intersecting a circle. And so I would give you an equation of a circle, and I'm just, by the way, I'm just randomly picking a question. So if it was x minus 3 squared plus y minus 4 squared equals 25, and I gave you the equation of a line of y is equal to x, and if you want to think about that, y is equal to x plus 0, and I ask you, where does the line intersect the circle? What I'm asking you is, when you have the circle, where does the line cross through the circle? What you do is you isolate one of your variables, and it just so happens it's already isolated. Y is x. You substitute that back into here. So if y is x, instead of putting, so I will do x minus 3 squared plus, instead of putting y is x, I'm going to put x minus 4 squared is equal to 25. Then I expand that out. So this would be x squared minus 6x plus 9. And this would be x squared minus 8x plus 16. And I move the 25 over. Minus 25 is equal to 0. So I would have x squared plus x squared is 2x squared. Negative 6x minus 8x is negative 14x. And 9 plus 16 is 25, and 25 take away 25 is actually 0. So this is what I have. I factor this. In this one, I would factor it to be 2x and x minus 7. Now, a lot of times it'll be a trinomial, and so you'll be factoring the trinomial. And if you can't factor the trinomial, if that's not something that you do easily, do the quadratic formula, that works too. But in this one, either 2x is equal to 0, which means x is 0, or x minus 7 is equal to 0, which means x is 7. So 0 and 7 are the 2 places where the line crosses the circle, so you need the y value. So you go back, and you can either go back to here, or you can go back to here. I'd go back here, it's easier. If my x is 0, y is equal to 0 plus 0, that's 0. And y is equal to 7 plus 0, so that's 7. So those would be the 2 points. So that is the first type of question. The second type of question out of section 8.4 is the equation of a tangent line. And so again, what I would be giving you is I would be giving you the equation of a circle. Just a second. I would be giving you the equation of a circle. So say x minus 1 squared plus y minus 4 squared is equal to 17 at the point 0 and 0. So basically, if I had this circle, so the center is at 1 and 4, and the square root of 17 is like 4 point something, and so the circle around it would be something like that. That's a really bad circle, but anyway. And we were to draw a tangent line at this point 0 and 0. What would be the equation of that tangent point? An equation of a line is always y minus y1 is equal to slope times x minus x1. And you're given an x1 and a y1. So this would be y minus 0 and x minus 0. The trick is you need the slope. The slope of a radius is perpendicular to the slope of a tangent. So if you can find the slope of the radius, and I know that the center is at 1 and 4, and I know that slope is y2 minus y1 over x2 minus x1, so that would be 4 take away 0 over 1 take away 0, so that would be 4 over 1. So the reciprocal, because the tangent would be the reciprocal, would be negative 1 over 4. So I would end up with y is equal to negative 1 over 4x, because I multiply it with this and I multiply it with that and work it out. So equation of a tangent. The last one in section 8.5 is the length of a tangent line. And this is where you would be given the equation of a circle. So x minus 2 squared plus y minus 2 squared is equal to 14 at the point 7 and 7. So again, what they're saying is that the center of the circle is at 2 and 2, and the radius is the square root of 14, which is going to be like 3.8 or 3.9. So it's going to be, I don't know, like this. And the point 7 and 7 would be like out here somewhere. So the question is, if I drew a tangent line, what would be the length from the point it touches the circle out to the 7 and 7? Well, we know the radius is the square root of 14. And if we draw another line from the center of the circle to here, what we actually have is a right angle triangle. So the center of the circle is 2 and 2. So the first thing I do is I actually find the length of the hypotenuse of this side by doing my length of a line formula. So that would be the square root of x2 minus x1. So let's say 7 minus 2 squared plus y2 minus y1. So 7 minus 2 squared again in this case. So 7 take away 2 is 5. 5 squared is 25. And so the other one would be 25. So I would have the square root of 50. So this is the square root of 50. If this is a right angle triangle, then let's call this x, then x squared plus root 14 squared would equal root 50 squared, right? Because that's just Pythagorean theorem. So x squared plus 14 would equal 50. So I move the 14 over. So x squared would be 50 minus 14, which would be 36. And so x works out to be 6. So the length of this line is 6. So again, find your radius, easy enough. Find the length of this line using your length of the line formula, then use Pythagorean theorem to find the length of the tangent. Same method every single time. That's why I like these. The method never changes. And then, pay attention to the directions. Do they say round the answer off to the nearest tenth? Do they say leave the answer in simplest radical form? Pay attention to how they actually want the answer written. And then we went to section 8.6, where we dealt with 90-degree triangles or right angle triangles, where we do SOHCAHTOA. So that's where we would do sine is opposite over hypotenuse, cosine is opposite over adjacent, and tan is, oh my goodness, cosine is adjacent over hypotenuse and tan is opposite over adjacent. I should get that right. And so if I say solve the triangle, again, that means find anything that is missing. So make sure that you do that. And then if you do not have a right angle triangle, if it's not a triangle that has a 90-degree angle in it, then we talked about possibly using the law of sine or using the law of cosine. Now you're doing homework on that right now, law of sine and law of cosine. Again, I have not gotten any questions yet, but I could. And so if I need to, on Friday, I will go over any questions that you have. If there aren't any questions, or if there's only one or two and it doesn't take me long, I'm actually going to start into chapter 9, because the quicker we can get chapter 9 done, the quicker we're done, and that's good for everybody. So we're going to do the test on Wednesday, but Friday and Monday, not Monday because Monday's a holiday, Friday and Tuesday, I actually plan to do some work out of chapter 9. Again, they are very, very different. There's no getting it confused. You're not going to go and try and do a method out of chapter 9 and chapter 8. It's not going to happen. So we will start into chapter 9, possibly Friday, unless there's an awful lot of questions. Probably Friday and Tuesday we'll do some of that. The first section is super, super easy, like super easy. I could teach it to my grade 9s and they could do it no problem. I could probably even teach it to grade 7 or grade 8 and they could do it no problem. It really is, if you can add, subtract, multiply, divide, you can do it. There's no fancy math in it at all. So I will start into that on Friday, most likely. All right, so we'll talk to you again soon.